Okay, so the problem that I got wrong for test number 4 was number 12. I'm doing an alternate version of that question. So this is an optimization problem, and where I went wrong was in the process of multiplying out this 12 minus x over 4, I didn't square the denominator, which is half the credit for this question, which is how I can do the video correction for this problem. So the problem I wanted to do was this problem that we got on our optimization worksheet that we didn't end up doing in class. So it starts with a trough is 2 meters long and its ends are triangles with sides of length 1m, 1m, and 1.2m as shown in the diagram, which is right here. And then you're supposed to find the volume V of the water in the trough, which is indicated by these wavy lines in the trough, as the function of water level h. H is right over here. So the second part is if the water is pumped into the empty trough at a rate of 6 liters per minute, find h as a function of the time t in minutes after the pumping begins. And it also tells you the conversion factor, which is 1 millimeter cubed equals to 1,000 liters. So this is going to be kind of hard to do because I can't have the problem pixels are too large to be open at the same time. So I'm going to have to cover over the problem. So you're asked to find the volume in terms of h. So looking back at the problem right here, I can't do that. Okay, looking back at the problem right here, you know that the sides are 1 right here and 1.2 and 1 on this side as well and 2 on this end. So if you start, you know that the triangle, so because volume is equal to base, the area of your base, which is why it's capital B, is equal to area of your base times your height. In this case, your height will be the length of the trough over here, which is 2, and then your area of your base is going to be this triangle. So the area of a triangle is equal to base times height over 2. Now, if you look at the problem, like the original triangle, it basically looks like this, which is, I'm sorry for this really bad drawing. I can't really draw on a computer. So it's basically 1 and 1 and 1.2. So if you divide and if you're looking for the height, this will be 0.8. Ooh, that's really crushed. Okay, it's going to be 0.8 because basically if you divide the triangle up, then this will be 0.6. And using the Pythagorean theorem, it will be 0.8. And this is basically your 3, 4, 5 triangle, almost. If you convert this into 6, 8, and 10, you can simplify it back into a 3, 4, 5 triangle. So this is a right triangle. And you're trying to find the length of, you're trying to find the area of this smaller triangle. Wait, I'll change the color so it makes it easier to see. Okay, so basically you're not finding this large triangle, you're finding this small, where the water level begins, this smaller triangle right here. Trying to find the area of that smaller triangle. So to find the area of they already give you the variable, right? So your variable that you're supposed to find in terms of is h. So because the smaller triangle, like this is a rough sketch, but let's say this is the smaller triangle in terms of the larger triangle, right? They both share the right angle and they both share this angle. And they both share this angle right here. So according to the angle-angle theorem, it's if two angles, corresponding angles in two triangles are congruent, then those two triangles must be similar. Knowing that these two triangles are similar and you have the measurements of the larger triangle, you can put them into a proportion, because you know that similar triangles are proportional, and solve for the smaller triangle in terms of the bigger triangle. So let's say this side is 0.6 over 0.8, right? Then you're going to set it equal to, this is the height of the larger triangle. You're trying to find, this is your H, this smaller section right here. This is your H. So you're going to set this equal, this 0.8, which is the height of the larger triangle, to the height of the smaller triangle defined by the variable H. And then you're going to set the top part, let's say, since this is the base of the bigger triangle, let's say you set it to B. But also remember, this is only half of your base, so later on you will have to multiply it by 2. So if you set this, it's going to be 0.6H equals to 0.8B. And you're solving for B, so you divide this by 0.8 over 0.8, and then you get B is equal to 0.75H. This is only if I use a different color, maybe I'll be able to show it better. Okay, so this is really only just half of your base of your smaller triangle. You're really trying to look for the whole thing, but because you're using the similar triangles, this only ends up being half of it. So your actual base is going to be 2b, which is just multiplying it by 2, which is 1.5h. Okay, now after you have that, you have to think back to your formula, which is your area of the smaller triangle, which is A is equal to BH over 2. So your area is going to be equal to 1.5h, because that's your whole base, 1.5h times h over 2, which ends up being 0.75 over, 0.75h squared. And then you plug this, because this is the area of your base, which is the capital B, in the formula equation. You plug this back into the formula equation, which is area of the base times your height. And since we said earlier that your height is basically this length of the right here, which is 2, you really just end up multiplying it back with 2, which is 0.75h squared, parentheses around that, times 2, and your volume is equal to, what did I just do? Okay, is equal to 1.5h squared meters cubed, because that's your unit for volume in this case. So now that you have your volume, you move on to the second part. Now, wait, I'm gonna box this to indicate volume. Okay, so this is your volume, and then you're looking for if water is pumped into the empty trough at a rate of 6 liters per minute, find H as a function of the time t in minutes after the pumping begins. So to start this, maybe I should open up a new one to have more space. Yeah, okay, so to start this, we're going to bring back our volume, which is equal to 1.5h squared meters cubed. Okay, so this is your volume, and you know that the rate that the water flows in is 6 liters per minute, but you're not in liters, you're in meters. So to use the conversion factor, one meter cubed is equal to 1,000 liters. You know that this is 1.5 h squared meters cubed, so you multiply this by 1,000 and you get 1,500 h squared liters. Now, after you find your liters, you're looking to define h as a function of time in minutes. So to solve for time is equal to volume over rate, because that is how long it will take the water to pump into the trough. So time is equal to volume over rate, and so your volume is 1,500 h squared in liters. So then you divide it by 6 liters per minute, which is equal to 250, I believe. 250 h squared minutes. Ooh, okay, so now you're going to want to solve for h in terms of time. So it's divided by 250 over 250. You cross this out, you get t over 250 is equal to h squared minutes. So then you find the square root of this and find the square root of this, and h is equal to square root of t over 250. And now that's finding h as a function of t in minutes after the pumping begins. So really it should be h of t, because you're finding h as a function of t. It should really be h of t equals to square root of t over 250. So that's your answer for B. And to reiterate, your volume is once again going to be, to part A, your volume is going to be 1.5 h squared meters cubed. And then your B is going to be h of t is equal to the square root of t over 250. Yep, and that's it.